This is over decimals and fractions part 2. So let's look at our number routine. Alike and different. What makes this alike and what makes it different? So I see the fraction 11/20th and I see the decimal 0 and 5500. So different. Well, one's a fraction, other decimal. That's what makes it different. I see, oh, one. They have different numbers. I see different numbers. Same. They are both rational numbers. Remember, what is a rational number? A number that can be written in fraction form. Well, this is a fraction. Can this be written as a fraction? Yes, it can be, as 55 hundredths. Wait, can't 5500 be simplified? Divide both numbers by 5, and you get 11/20. Oh, they are the exact same number. 11/20th is the same as 55 hundredths. Another way to do it is, remember, out of 100, if I multiply 11/20 both by 5, I get 5500, which is 55 hundredths, or 11/20. So they're the same rational number. All right, a Japanese beetle has a length between 3/10 and 5/10. Find two lengths that are within the given space, express them as fraction. So I will use 0/4, and what about 35 hundredths? So they are between these. So how would you write this one? 4/10. It's in the tenths place. And how would I write this one? This is 35 hundredths. So let me get my pen. So 4/10, 35 hundredths. Can I simplify 4/10? I think I can. I can divide both numbers by 2. So that leaves me with 2/5. And this one, I can divide both numbers by 5. I'm going to rename it and simplify. So that leaves me with 7/20th. So 2/5 and 7/20 or 4/10 or 3500 meet the requirements. So what do you remember about rational numbers? It says in this one, classify these. 12, 4, and so on. So 12/4. What is 12 divided by 4? Well, 12 divided by 4. Wait, 12 divided by 4. That could be a whole number. That's 3, isn't it? That could be an integer, and it could be a rational number because it's already in fractional form. It's in all three. You can classify it as all three. What about this one? Absolute value of -3. That is just 3. And it goes in all three levels. 5, 6. Is that a whole number? Nope. Is that a whole number and its opposite? Nope. So it's a rational number. 9 and 2/10. Is that a whole number? Nope. Integer? Nope. It is another rational number. What about 0? 0 is a whole number. Is it integer? Yes, it's a whole number is the opposite. And can that be written as a fraction? Yes, it can. 0/1. And -8. Is -8 a whole number? Nope. Is -8 integer? Yes, it is. It's whole numbers and opposite. And can -8 even be written as a rational number? Yes. -8 divided by 1. So, how do you know? How do you know 8/10 is equivalent to 4/5? How do you know that? Well, 0.8, that goes in the tenths place. So that's 8/10. Can you simplify 8/10 to 4/5 by dividing both numbers by 2? Yes, so 8/10 is equivalent to 4/5. How do you know 45 hundredths is equivalent to 9/20th? If I divide both numbers by 5, I get the ratio or fraction of 9/20th. So 4500 is equivalent to 9/20th. How do you know that 2 and 24 hundredths is equivalent to 6? Oh, let's do it backward. Could I do out of 100? How do you build a 25 to 100? I multiply both numbers by 4. So I get 2 and 24 hundredths, which is equivalent to 2 and 24 hundredths, or 2 and 12 fiftieths, or 2 and 6 25ths. So in this one, you will be given a fraction in this activity during class, such as, I don't know, 6 out of 50th. You must determine, does it go out of 100? Yes or no? Is this a multiple of 100? Let's see. Let's see. Is the denominator 50 a multiple of 100? It is. How many groups of 50 go in 100? Times 2. Times 2. So it can be rewritten as 12 hundredths, or the decimal of 0 and 12 hundredths. What if you are given the fraction of 7/8? Can this, is the denominator a multiple of 100? Or in the tens? It is not. So I cannot do a shortcut. I'm going to have to divide it. So there are two ways to turn a fraction to a decimal. Sometimes you could do out of 100, using a denominator as a multiple of tens or 100, or sometimes you can divide it. Like, for example, 3 is divided into 4 groups, or 3 divided by 4. That's called top typo. Top goes in, bottom goes out. That means the dividend is being divided by the divisor. So let's look at our first example. We have the fraction 2/5. This says 2 is divided into 5 groups. Number sense first. Is this number going to be more than half or less than half? Let's think. Half of the whole here is 5. Half of it is 2.5. So this is, I predict it's going to be less than half. So it says, so I think it's going to be, answer will be less than 50 hundredths. So 2 divided by 5. So I have 2, I'm dividing it into 5 groups. Can 5 go into 2? It does not, 0 times. So if I subtract this, I get 2. 0.0. Again, by putting a 0.0, am I changing the value of 2? I am not. That's why you have to put the decimal point 0. Bring down 0. Can a group of 5 go into 20? It does. It goes in 4 times. So 2/5 is equivalent to the decimal of 0 and 4/10. To check your work, what did I say again? 0 and 4/10. So I rewrite this to a fraction, 4/10, and that's simplified to 2/5. So they are all equivalent. Some of you may prefer, you don't like dividing. So can 5 go into 10? 2 times. 2 go into 4? 2 times. So 2/5 is equal to 4/10, which is equal to decimal of 4/10. So do you prefer dividing it? Or do you prefer doing multiples of 10 or 100? It's up to you. And is 4/10 more than half or less than half? It is less than 5/10 or half. Next one, 9/5. Is this going to be more than 1 or less than 1? If I have 9 and I need to divide it into 5 groups, think about it. You have $9 and you want to divide it into 5 groups. I predict they're going to be more than 1. So I'm going to divide this. 9 is divided into 5 groups. Can 5 go into 9? 1 time. So if I subtract 9 minus 5, I get 4. I need to get rid of this remainder. We're not in elementary school anymore. So to get rid of it, I put a 0.0 here. Does that change its value of 9? Does not. Oh, I always forget to put a decimal point here. Let me put it there. Bring down 0. Can 5 go into 40? Hey, it goes in 8 times. So The decimal equivalent is 1.8 or 1 and 8 tenths, which can be renamed as 1 and 4/5, which can be renamed as 9/5 using turning the mixed number to improper. 5 times 1 is 5 plus 4 is 9/5. They are all equivalent. 9/5 is equivalent to 1 and 8 tenths, equivalent to 1 4/5, which is equivalent to the decimal 1 and 8 tenths. And it is more than one whole. Let's practice another terminating decimal. Terminating are decimals that stop. This shows 3 is divided into how many groups? 8. Well, do you predict this is going to be more than half or less than half? What is your prediction? I predict it's less than half because the whole is 8. What's less than half of it? 4. That's less than half. So it says 3 divided into 8 groups. 3 divided 8 groups. If you have a hard time remembering this, some people use typo. Top number goes in the division bar, the bottom goes out. If that helps you. I just think of it as at 3, I need to divide it into 8 groups. Can 8 go in 3? 0 times. How can I get rid of this 3? I put a 0.0 because it does not change the value of 3, as you can tell. How many groups of 8 go into 30? It goes, oh, forget the decimal here, 8, 16, 24. It goes in 3 groups of it. So 30 minus 24 is 6. How do I get rid of this 6? I add another 0 here. Again, that does not change its value of 3.00. Same thing as 3. How many groups of 8 go into 60? 8, 16, 24, 32, 40, 48, 56. 7 groups. So 60 minus 56 is 4. I'm hoping this terminates and ends. Or it's going to be something called a repeating decimal. Bringing down to 0. How many groups of 8 go into 40? 8, 16, 24, 32, 40. 5 groups. So the decimal equivalent is 375,000 is the same as saying 3 divided by 8 or 3/8. And that is less than 500,000 or 1/2. What if you are given a mixed number? Can you find its decimal equivalency? Some of you prefer out of 100. Let's look at the denominator. Does the 50, is it a multiple of 100? It is. It goes in twice. 50 goes in 100 twice. So what's twice of 9? 18. So 3 and 9/50 is the same as saying the place value of 3 and 18 hundredths. And that's the decimal. But you know what? Some of you may prefer dividing it. This says 3 and 9/50. So I need to divide 9 into how many groups? 50 groups. So 9 is divided into 50 groups. Can 50 go into 9? I don't think so. 0 times. So how can I get rid of this 9 without changing its value here? Put a 0.0. Oh, don't forget a point here. I forget it myself. How many groups of 50 go into 90? Well, of course, only one group. Because 2 groups is 100. That's too big. 40. How do I get rid of this 40? Add another 0. Bring it down. How many groups of 50 go into 100? 50, 100, 150, 200, 250, 300, 350, 400. 8 groups. Hey, I see the decimal of 1800s. But what's the whole number? So it's 3 plus 1800 is equal to 3 and 18 hundredths. It's equivalent to 3 and 9/50. So, as we continue on, let's match stuff here. 2/3. Do you know another way of saying this? 2 divided by 3. Which one would it be? 2 divided by 3. Oh, 2 divided into 3 groups. This one. This one shows 3/2 or 3 divided by 2. And it's this one. Next one. Ooh, let's make it a little harder. A divided by B. Oh, right there. Remember, you cannot have 0 on the bottom because you cannot divide. You can't put things into 0 groups. Divide things into 0 groups. Diamond divided by square. Diamond divided by square. Diamond is divided into square groups. So it'd be that one. All right, now let's talk about repeating decimals. So what we have been doing so far is doing terminating decimals. Decimals that just stop. So in the first repeating decimal, we see the fraction of 1/3. Do you predict this is more than half or less than half? Let's think. The whole is 3. Half of it is 1.5. So I predict that this will be less than half. Let's see why. So this is 1 divided by 3. So I have 1. I'm dividing into how many groups? 3 groups. Can 3 go in 1? Of course, 0 times. If I subtract this, I get 1. How can I get rid of this 1? Put a decimal 0. Remember, it doesn't change its value of 1. Bring it down. How many groups of 3 go into 10? 3 groups, which is 9. 10 minus 9 is 1. I need to get rid of this 1. Add another 0. Another 0. How many groups of 3 go into 10? 3 groups. Hold up. Are we repeating ourselves right here? I felt like it's like deja vu. I felt like I've done this before. Oh, it's repeating. To show repeating, you draw a repeating bar over the number or numbers that repeat. The 3 is repeating, so I draw a repeating bar notation on top of the 3, showing it repeats. So that means it will be 0.33333333333. I'm not going to sit here and write it over and over. So that's why I put a repeating bar notation. And it's less than half, or less than 50 hundredths. 2/3. Do you predict this is more than half or less than half? I think it's going to be more. Let's see. 2 divided by 3 groups. I have 2. I'm dividing into how many groups? 3 groups. Can 3 go into 0 times? How do I get rid of this 2 without changing this value here? Put a 0.0. So I bring it down. How many groups of 3 go into 20? 3, 6, 9, 12, 15, 18. 6 groups. So 20 minus 18 is 2. I need to get rid of that 2, but add another 0. Can groups of 3 go to 20? 6 times, which is 18. I almost feel like it's deja vu. Wait, it's repeating again. So what number is repeating over and over? The 6. So I'll put a repeating bar over the 6. 0 and 6600, but it keeps repeating here, 6666. So it really is not going to be in the hundreds. It's going to be repeating 0.666666. And it's more than 50 hundredths, or half. What about 2/9? Do you predict this is more than half or less than half? I think it's going to be less than half because 2 is 4.5 is half of 9, way less. So I have 2, and I'm dividing it into 9 groups. Can 9 even go into 2? 0 times again. If I subtract this, I get 2. I need to get rid of this 2. So I put a 0.0 so it doesn't change its value. How many groups of 9 go to 20? 2 times. That's a 2, by the way. 20 minus 18 is 2. I need to get rid of this 2. add another 0. How many groups of 9 go in 20? 9, 18. 2 times again. Uh-oh. Deja vu. 20 minus 18 is 2. I'm going to stop. It's repeating again. So what number is repeating over and over? The 2 is repeating, so I'll put a repeating bar notation on top of the 2. And it is less than half. 7 and 5, 6. That really is saying I'm adding the whole number 7 with 5, 6. So let's find what this is. Let's turn the 5, 6 to a decimal. That's 5 divided by 6. So 5 is divided into 6 groups. Can 6 go into 5? 0 times. So I have, how do I get rid of this 5? 0.0. I bring down the 0. How many groups of 6's, oh, forget my decimal point. How many groups of 6's go into 50? 6, 12, 18, 24, 30, 36, 42, 48. 8 groups. 50 take away 48, you're left with 2. 0, bring it down. How many groups of 6's go in 20? 6, 12, 18. 3 groups. 20 minus 18 is 2. I'm going to get rid of this 2. Add another 0. Bring it down. How many groups of 6's go into 20? What? Deja vu. Didn't we just do this a few seconds ago? 3. Oh, it's going to keep repeating. Yep. So what numbers were being repeated? The 8, the 3, the 83, the 3? Only the 3 is repeating, so I'll put a repeating bar notation on top of the 3. So it says, so 5, 6 is equivalent to 0 and 83, repeating bar. So the decimal is 7.83 with the bar notation, repeating bar on top of the 3. So here's our last example. Is 1/8 a terminating or repeating decimal? What is your prediction on this? I think, you know what, I'm going to have to divide it. Again, this shows 1 is divided into 8 groups. I think it's going to terminate. Let's make sure. Let's prove to me it does. Can 8 go into 1? 0 times. So I have 1. How can I get rid of this 1 without changing this? Put a 0 here. How many groups of 8 go into 10? It goes in 1 time. 10 minus 8 is 2. I need to get rid of this 2. Add another 0. Bring it down. How many groups of 8 go into 20? 2 groups. So 20 minus 16 is 4. Add another 0 here. Bring it down. How many groups of 8 go into 40? 5 times. And it does terminate. So it was 0 and 125,000 is the answer. So what we've just done is how to turn a decimal to a fraction using place value, or a fraction to a decimal doing multiples of 10 with a denominator or hundreds, or dividing. I prefer both. I do like dividing it out because you look at the numerator, the dividend is divided by the divisor. And this is that study.